In this example, we'll conduct a hypothesis test that's two-tailed. A survey showed that among 785 randomly selected subjects who completed 4 years of college, 18.3% smoke. Use a .01 significance level to test the claim that the rate of smoking among those with 4 years of college is different from 27%, which is the rate of smoking among the general population. Okay, so we have a sample size of 785 and an alpha of .01, and again they didn't give us x, so we'll calculate it. We know that our p hat taken from the sample, they found the proportion to be 18.3% or 0.183, so we'll find x by multiplying p hat times n. 0.183 times 785. And we get about 143.7. Now, we can't have 143.7 people, so what had happened was whatever the number that they had, they calculated a p hat, and then it was not a whole, it was not truncated at 1 decimal place, so they rounded to 1 decimal place here. So it was actually had more decimal places than this. So what we do is we just say we'll round that to approximately 144 subjects who smoke out of the 785. Okay. So now we need our original claim. And you see we use this original claim to help us determine our alternate hypothesis and to write our conclusion. So it's important to get this down. So the original claim says, test the claim that the rate of smoking is different from 27%. So different from means it's not equal to 0.27. That's how it would be different. It doesn't say it's greater than. It doesn't say it's less than. It just says it's not 27%. So that's what we say. Our competing claim. Well, not equal to 0.27 covers everything except equal to 0.27. Oh, can't get rid of that thing, sorry. Okay, here we go with our null hypothesis. P is equal to 0.27. No thought really there. We know we're always going to use the equal sign. Here's where we have to stop and think. The alternate hypothesis. Okay, the competing claim contains the condition of equality, so the alternate hypothesis will be the original claim, not equal to 0.27. So here's where we see we have a two-tailed test. Okay, so let's remind ourselves we will be finding a critical value using inverse norm, a test statistic from the calculator, p-value from the calculator. We'll make a decision using all that information in our decision diagram. Okay, so let's see what that decision diagram is going to look like. This time we have two test statistics, one on the right side, one on the left side. And two critical values. I'm not thinking here. We won't have two test statistics. We'll have two critical values because we have a two-tailed test. And our alpha was equal to 0.01, but we'll have to split that and have alpha over 2 on each side, or 0.005 here and 0.005 here. Okay, so now we use the inverse norm function, and to find this one, area to the left is 0.005, we would expect to get a negative z-score, and you do. Rounded to 2 decimal places, you get negative 2.58. So this critical value is negative 2.58. Now you can also calculate inverse norm with the area of 1 minus 0.005 to get this one, but we know we have a symmetrical graph, and this should be the positive 2.58. Okay, so let's indicate that up here, and the way we do that, we have z-scores that are equal to plus or minus 2.58. It's one way to show both of them. Okay, now we're ready to use our one proportion z-test. Okay. Alright, our p sub 0 said 0.27. The x we calculated and did a little rounding to get 144. Our n was 785 subjects in the survey. And this is a two-tailed test, not equal to. So I'm going to highlight that and calculate. Okay, so here's my test statistic, my z-score of negative 5.4627, which I would round to negative 5.46. The p-value, we again see this number that looks like it's greater than 1, which doesn't make sense for a probability, but notice it's in scientific notation, times 10 to the negative 8, which means we'll move the decimal place 8 places to the left, and once you do that and round to 4 decimal places, you'll see it's essentially 0. Okay, so let's record those results. Our test statistic was negative 5.46, and our p-value we said is essentially 0. I'm going to record it as 0.0000. That shows in 4 decimal places, that's all I have are zeros. Okay, so we have 2 critical values and 1 test statistic because we just said it's different, and it turns out from our test that we ran, we're different in the negative direction. So negative 0.46 would be out here somewhere. I'm sorry, negative 5.46 would be out here somewhere. And here's the p-value associated with that. Now it's really tiny. You recall that we were using a z of negative 5 to represent negative infinity before, and when we were doing problems involving the continuous probability distribution, the normal distribution, we said, well, we can just use negative 5 to represent negative infinity because there's essentially nothing out past that. Well, you can see we get 4 zeros here when we get out to negative 5.46. So really you wouldn't even see this much, but I want it to make some sense, so we have a little color there to show that. Okay, let's do our test and make our decision. We compare these two. Does the test statistic fall within the critical region? Well, it does. It falls in the left side of the critical region. That would indicate we reject the null hypothesis. Is the p-value less than alpha? Well, it certainly is. So that tells us we will reject HO. Okay, all we have left now is to write our conclusion. Okay, does the original claim contain the condition of equality? No, it does not. It's the competing claim that has that. So the answer to that question is no. Do we reject the null hypothesis? Yes, we do. So our conclusion states there is sufficient evidence to support the claim and our claim was that the rate of smoking was different there is sufficient evidence to support the claim that the rate of smoking among those with 4 years of college is different. From 27%. The rate of smoking among the general population. Okay. So from what we found, we rejected the null hypothesis. Remember, the null hypothesis is not the claim, right? The null hypothesis goes with the competing claim. So we reject this, so that means we have evidence to support our claim. There is sufficient evidence to support the claim. Okay, and we're done.